this is section 2.9, and this is the first section of the year, so a couple things to go over. You have these slips of paper you can pick up in the classroom that ask you to put some information on here that you'll then staple to your assignment. But on this, it's going to ask for your learning intentions. These are the things that I hope that by the end of this lesson you understand. If you don't, that's something you need to check with me on. But the first, our learning intentions for today are the student will be able to graph absolute value functions and perform transformations of absolute value functions. So those are hopefully, when we finish with the section, what you'll know how to do. The other thing is that you're going to add to this piece of paper is vocab that we're going to go over today, that hopefully some of this you already know, but it's important stuff that you need to know to do the assignment. And so we'll go through this vocabulary, and you want to write these down on the piece of paper. So you're going to put absolute value functions, parent function, domain, range, transformation, vertical, horizontal, stretch, compression, shifts, which is also another term, translations, and inverse operation. And those we'll go through, but by the end of this, you should know what all these terms mean. So what we're covering today is absolute value functions. Now, a function is anything that, as you go through your day, you expect things to occur in functions. If you buy a pop for $1.50 and then you come up and buy another one, you expect it to be $1.50 again, or someone else. Things that are not a function are your height and your shoe size. Okay? You want some things to occur the same every time you put an input in, that the output's the same. That makes it a function. So like your calculator, every time you put in a set of instructions in your calculator, you expect the next time you put in the same exact steps, you would get the exact same answer, or your calculator is no good. You would not expect height and shoe size to be a function, because not everybody that's 6 foot tall has the same shoe size. So that's what a function is. Absolute value, remember, is the distance from 0. So the absolute value of 3 is 3 because 3 is 3 units from 0. And the absolute value of negative 3 is also 3 because its distance from 0 is 3. So those are terms you should know already. But absolute value function is a function that contains absolute value in the expression. So in this case, f of x, that's a way we can write functions. They'll use f of x, g of x, h of x usually in the book. But it can be any letter. But this says the function of x is the absolute value of x. So that's the rule that we're going to use in this case. In this case, when we have this f of x equals the absolute value of x, it's called the parent function of absolute values, because it's as simple as absolute value function as I can make. There's nothing multiplied to it, added, subtracted, any of that. In that case, the domain is your input numbers. So if we take this parent function, and we say x, and then our f of x, which also you can put as y, what you're more familiar with, is the absolute value of x. If I plug in negative 2, I plug it in here, the absolute value of negative 2 is positive 2. If I plug in negative 1, the absolute value is 1, 0, 0, 1, 1, and 2, 2. So that if I was to graph this parent function then, at negative 2 we're at 2, at negative 1 we're at 1, at 0 we're at 0, 1 we're at 1, 2 we're at 2. And so it gives us this type of graph. And when you do absolute value functions, you'll always get either this V look, whether it's wider or narrower, left or right, up or down. You'll either get that look or it flipped over like a TP. So the domain is all real numbers. Domain is your input numbers. I can put any value I want in for x. I can put fractions in, I can put decimals in. Positive, negative numbers doesn't make any difference. The range is your output numbers. Those are the numbers you get out. Well, when we look at this, the smallest number we get out is 0. All other numbers are greater than that. We'll never get a negative number out of this function. And so our range is our output numbers, and that would be the non-negative real numbers, or you could write that as y, because that's our y values, or f of x, is greater than or equal to 0. And the vertex, which is our turning point, is 0, 0. Now, g of x, if we go back to our parent function, let's say f of x is the absolute value of x. These are all things that can affect the absolute value of x. A would be a number multiplied outside of the absolute value. B is a number multiplied by x inside the absolute value. H is a number that's added or subtracted inside the absolute value. And K is outside. These are the transformations of the image of f of x equals the absolute value of x. So remember, transformations from geometry, that is, I could slide this left or right, I could slide it up and down, I could slide it at an angle, I could rotate it, I could dilate it, make it bigger or smaller, I could stretch it, I could compress it, I could reflect it. So there's all these transformations we can do, and that's what this does, is it affects that f of x equals the absolute value of x. And we're going to learn how a, b, h, and k all affect this parent function. Now, this is the same, as we go through the year, we're going to do functions all the time. And the way a, b, and h, and k affect the function always stays the same. So if we can learn it once really well, we can apply it as we go through the year. The b, we don't use that a lot, but I want to show you now so that we don't have to change it later on and add it in, so that way you have everything for the year. So transformations. Let's take a look at the A first. A is a vertical stretch or compression. It's either going to take the graph and stretch it vertically up or vertically down, or it's going to compress it vertically. So it can do both of those. It stretches it if A is greater than 1. Now that's the absolute value of A. So if A was negative 3, it would still be a stretch because the absolute value of negative 3 is 3. So if A is greater than 1, it's a stretch. If the absolute value of A is less than 1, then it's a compression. Okay? So you can look at the graph, and let's say that g of x equals 3 times the absolute value of x. This would be a vertical stretch of 3. If it was negative 3, it would still be a vertical stretch of 3 because the absolute value of negative 3 is still 3, and so it's still a vertical stretch of 3. If it was 1/5 x, then that would be a vertical. It's vertical because it's outside, and since it's less than 1, that would be a vertical compression of 1/5. And so all you have to do is look at A, decide is the absolute value greater than 1, or if the absolute value is less than 1, that will tell you whether it's a stretch or compression. We already know it's vertical because it's outside. The A is the value outside. If A is negative, then the absolute value of the graph flips vertically. So these negative signs, this negative 3 here, would stretch it by 3, but then it would reflect it down because the parent function goes up. So a negative sign just will reflect it vertically. So, and remember, vertical is up and down. So if it's up, it reflects it down. If it already was down, then it would reflect it up. B, okay, so the B value is inside the absolute value. It's still multiplied. And so B, again, if B is horizontal, it's a horizontal stretch or compression. If the absolute value of B is greater than 1, it's a stretch. If the absolute value of B is less than 1, it's a compression. So you can see the wording of this is the exact same as the A. The only difference is the A's have become B's. But there's a huge difference when we do these. And this is what's difficult for most people. If I said that the function was the absolute value of 1/5 x, the first thing we have to do is decide what b is. And remember, our formula is 1 over b. So it's 1 over b, so b is 5. Now I know that 5 is greater than 1, so that would be a horizontal stretch of 5. But what if it was, let's say, 3x? Well, to find out what b is, mathematically I can solve that. I can just go here and say, let's let so it's 1 over b. That's this 1 over b here. Has to equal 3. And if I was to mathematically solve this, I could multiply both sides by b. The b's would cancel over here. I get 1 equals 3b. Then I would divide by 3 and get 1/3 equals b. So in this case, b is 1/3. And so that would be, again, it's horizontal because it's inside. But it would be a compression of 1/3. All right? Again, if b is negative, it flips it horizontally. Okay, so if I put a negative sign in here, it flips horizontally. But here's the thing. When we have our graph, wherever that's located, if I flip it horizontally, again, it's on the vertex. Well, if I flip that, this side would go here and this side would go there, and you couldn't tell. It would look the exact same. So there's really no difference when you flip it horizontally here. And then the last two things we're going to look at is h and k. H is a horizontal shift. Horizontal would be left and right. And k is a vertical shift, up and down. Now again, here's where we have to be careful. If it says f of x equals x minus 3, well, remember our rule is a times x minus h. Let's just put in the 1 over b. A times the absolute value of 1 over b, x minus h plus k. Well, this minus 3, h would have to equal, for that to be, h has to be 3 to get minus 3. So you can see here again, it's the opposite of what it says. Just like with the b, it was the reciprocal of what it said, the multiplicative inverse. Remember, inverses are opposite operations, so if it's multiplication, the multiplicative inverse is the reciprocal. And the additive inverse, since it's added or subtracted, would be the opposite, which would be 3. And so this would be, you don't need to put horizontal because you're going to say shift right 3. And if I had a plus 2 there, then that's our k value. And our k value is 2. And so that's going to, again, you don't need to put vertical. But it's, the k is outside, so it's up and down. So shift up 2. All right? So there's a lot of things to do here, but to summarize this and hopefully to make it really clear, so again, we've got our parent function. F of x equals the absolute value of x. And we've got this transformation we're going to do. And we put these letters in there just to represent them. Okay? If the value affects the absolute value. Okay? So if it's outside the absolute values, so A and K, it is a vertical transformation, up and down. Okay? If the value affects the X, so that would be inside the absolute value, then it is a horizontal transformation. And here's what's important. It's the inverse of what it says. So if it's added or subtracted, it's the additive inverse. If it's multiplied, it's the multiplicative inverse of what it says. Okay? So, outside, vertical. Okay? If it's multiplied, then it's a stretch or compression. Depending on if A is greater than 1 or less than 1, the absolute value. If it's inside, let's go back here. If it's added or subtracted, then it's a slide. Okay? Positive up, negative down, because it's again, this is all vertical. If it's inside, then it's horizontal. Easy way to remember this, remember the letters that are inside. The H is inside for horizontal. Then, it's always the inverse of what it says. Okay? And again, if it's multiplication, it's a stretch or compression, and addition or subtraction, it's a slide, just left or right, because it's horizontal. So on these sheets, I'm going to give you 3 examples, and I want you to put these examples on the sheet. So let's do a fairly easy one to start with. Let's do, our first example would be f of x equals negative 3x plus 2. All right? So things that might help you. Remember, vertical, outside, horizontal, inside. Multiplication, stretch, or compression. Addition, subtraction is a shift, or slide, or translation. Okay? So, as I look at this problem, just take each part one at a time. That's multiplied. It's outside, so it's vertical. Multiplication is a stretch or compression. The absolute value of negative 3 is greater than 1. So our A value is negative 3. And so that would be a vertical stretch of 3. We don't add the negative sign in our answer, because remember that negative sign is another transformation. It flips vertically. Because it's outside, so it's vertical if it's outside. There's nothing else outside, so now let's go inside. The b value is 1, so that doesn't, multiplying by 1 doesn't change it, so we don't need to worry about that. So we only have to worry about the 2. Let's do that in blue. The 2, so that's our h value. It's inside, right? And so if it's inside, it's the inverse of what it says. The inverse of plus 2, additive inverse of that is negative 2. And so remember, if it's added or subtracted, it's a shift. And so this shifts negative 2, so to the left. So it shifts left 2. And that's all you have to do to describe the transformations. Now, one other thing I should have gone over earlier. The vertex, remember it was 0, 0? Well, the vertex will always be HK because it shifts it left and right. The A and the B just stretch it or compress it so they won't move that vertex point. So if I was to ask the vertex for this, the vertex would be located at H, which is negative 2, and there is no K, so it would be at 0. They asked that on the assignment. So that's the first example. Let's do another one. We're going to do 3 of them. So the second one, example 2, we'll make this a little more difficult. Let's go f of x equals 1/5 3x plus 4 minus 2. Okay? So again, remember, outside, that's vertical. Okay? So the A is 1/5. The absolute value of that is still 1/5. It's less than 1, so it is a vertical compression. Just tell what way it is. So vertical compression of 1/5. Then let's go, it doesn't make any difference what order you do these in, so let's take care of all the vertical stuff. So that's our K value. K is negative 2. Remember, if it's outside, it's what it says it is. And so that would be, again, it's vertical, so up and down. So shifts down 2. Now we go to inside. So I'm going to start here with the 3. Remember, we have our B value, and anything that's inside, horizontal, it's the inverse of what it says. So the inverse of 3, it's multiplied, so we want the multiplicative inverse. So that would be the reciprocal, 1/3. That is less than 1. Inside is horizontal. And so that would be a horizontal compression of 1/3. And the last thing we need to take care of is the 4, which is our H value. Again, it's inside, so it's the inverse of what it says. The opposite of plus 4 is negative 4. So that would be shifts left 4. And if they ask for the vertex, remember the vertex is always HK. And so in this case, my vertex would be at negative 4 and negative 2. All right? One last example to put on your paper. Let's do So as we look at this, again, we want to take each part. This is our vertical stuff, outside. So a negative sign, it's really just a -1. So the 1's not going to stretch it or compress it, it's going to stay the same. But the negative sign reflects vertically. Okay, so it's going to flip it over. The -2, again, it's outside, it's vertical, it is what it says it is. So it shifts 2 down, or down 2. And the last thing to take care of is the stuff inside. So the 3, remember inside it's the inverse of what it says, so it's -3. It's added, so it's a slide. So that would be shifts. Left 3. So this time I didn't put what A, B, H, and K were. I just went through and wrote this. This is fine on your assignments to write it this way. All right? If it helps you to label everything A, B, H, and K and write that out, then by all means do. If I wanted the vertex here, my vertex, remember, would be HK. So it's the opposite of that, so -3, -2. So hopefully this has helped. Your assignment is page 161, numbers 9 to 23, the odds, and then number 27 and 29. Make sure if you weren't in class that you get one of these. You fill out the information, put the examples on there. You're going to staple this to your assignment when you turn it in. And then at the bottom it asks you to write your level of understanding. A 1 would be you don't understand it at all. A 5 would be if you feel really, really good about it. You're pretty sure you know exactly what to do on everything. So good luck on this. I hope it helped.